Welcome to Python Metaclasses. My name is Chris, and I will be your guide. This course is about a tiny little corner of Python, how the machinery behind classes work, and how you can hook it. This course is not for the faint of heart, and you could go your entire programming career without ever using any of it. If you're curious about how classes get instantiated, or are interested in writing frameworks where a lot of magical things happen behind the scenes, this course might be for you. To get the full picture of a metaclass, first you need to understand how everything, and I mean everything, including classes in Python, is an object. What the type function does, how classes instantiate objects, how classes, which are objects, get instantiated, and how to hook that for fame and profit. Right, maybe not fame and profit. How about esoteric code goodness instead? This course was tested using Python 3.11.2. Most of the concepts introduced here have been around for a while. If you're using Python 3.7 or later, you should be good. Although metaclasses do exist in Python 2 after 2.2, the syntax for it is significantly different. I'll be sticking with Python 3 throughout the course. You'll be tired of me saying it by the end of the course, but everything, including classes, in Python is an object. When you create a class, you are implicitly instantiating it, and the underlying mechanism used by Python to do this is available to you as a programmer. This can get a little tricky. You're creating things that create things, and that level of abstraction can warp the mind a little bit. 3 cases where metaclasses are used are a factory pattern, where the creation of an object is supposed to have a side effect, like registering it with a central store; singletons, where you absolutely positively only want a single instance of an object. You can enforce that using a metaclass by controlling how the class instantiates objects; and frameworks like Django and SQL Alchemy that use metaclasses to perform the magic relationship between ORM object attributes and database tables. In fact, the Python standard library uses metaclasses to implement the enum class. Once I've covered the concept of metaclasses with you, I'll walk you through enum and its companion, the enum type, to show you a real-world use case. Before going all meta, you'll need to understand the intricacies of classes and the type function. That's what's next. In the previous lesson, I gave an overview of the course. In this lesson, I'll be covering the type function, the type, and classes. Everything in Python is an object. It's déjà vu all over again. Thanks, Yogi. Each of the objects has a type. The type indicates its nature. A number has the type int, text has the type string, and an instance of a person object has the type person class. The type function tells you what type an object is. Let's go play with it in the REPL. Let me start out by writing a list. Calling the type function on it returns the fact that it is an object instance of the list class. Here's one of the cats, and the type of that is string. Interestingly, it's turtles all the way down. Here's the third letter of tiger, whose type is also a string. That's a bit different from other programming languages that make a distinction between a character and a string. Strings and their substrings are both strings in Python, right down to single-letter instances. How about when you write your own class? I've kept it simple here, creating an empty class. Here's an instance. And hopefully that's not a surprise that the type of the instance is the dog class. The dunder main prefix on this is because I'm in the REPL. If the class were declared in a module, you'd get the module name as the prefix instead. Let's try something else. That's the max function from the built-in library. And that's max's type. Handy that Python distinguishes built-in types from others, huh? Let me create a class inheriting from enum. And get an instance. Good feathers, shout out for the win. There's the instance. And its type. That shouldn't be too surprising, as that's how it was built. Do note that it isn't calling it a class, but an enum. We'll come back to that later. Let's go a little meta. The type of the instance is birds, but what is the type of birds? Well, it's a class called enum type. Same as enum itself, which sort of makes sense as birds inherits from enum. There's a transitive thing going on here. Let's go grab enum type. And look at it. Now that's a little weird, isn't it? The type of enum type is type. Remember dog? Yep, the same thing. Same thing actually goes for built-ins. Type of a list, type of a float, they're all type. The type is the top level of the class hierarchy. In fact, you can think of the type function the same way you think of the string function. When you call string on something, it returns its string equivalent. When you call type on something, it returns its type equivalent. It bears repeating, type is the top of the hierarchy. Let me show you. Yeah, the type of type is type, which you get by calling type. Does that clear it up for you? This is the first of the brain-melting bits on the way to metaclasses. Let's go talk about classes, and hopefully it'll become a little clearer. Python has had classes and objects from almost the beginning, but how they were built changed in Python 2.2. In this version, they added the idea of a base object that everything can inherit from. Up until Python 3, both the old style and new style of classes was supported. If you've done some object-oriented coding in Python 2 and had your class declaration inherit from object, this is why. Python 3 got rid of the old style. You can still use the new style declaration inheriting from object, but if you don't, Python uses the new style anyways. This saves some typing, but can cause some confusion for folks who are going back and forth between Python 2 and 3. Hopefully that's fewer and fewer of you nowadays. Let me demonstrate these different class declarations in the REPL. I'm in a 2.7 REPL. Let me just prove that. See, 2.7.18. Now let me declare a class using the original syntax. If you've used Python 2's new style, note that I've not inherited from object here. This can actually be a source of a tricky bug in Python 2. If you mean to use the new style and forget the object inheritance, your classes may not behave the way you expect. Anyway, let's play with the old style for a bit. There's my Apple instance. And the dunder class attribute of an object indicates what class it's from. Here, it's showing that Apple is fruit declared in dunder main. Again, being in the REPL is what causes dunder main to be the module name. Running type on Apple gives instance. That's an old style thing. Running type on the class itself gives class_obj. Again, an old style thing. All right, out with the old. Let's talk about the new. In this case, new is kind of relative. It was introduced in Python 2.2, which was released December 21st, 2001. I suspect some of you may have been born after this new thing. Anyhow, the relativity of new notwithstanding, let's use it. The new style class declaration inherits from object. You can actually come at this the other way around. Inheriting from object is what distinguishes this as a new style class. Without object, you get the old style class. Offer limited to Python 2, offer may not be valid in some states, buyer beware, caveat emptor, etc., etc. Carrot is an instantiation of vegetable. Carrot dunder class is dunder main vegetable. The only obvious difference between the string representation of the old and new class is the old class includes an object ID reference and the new one does not. The type, on the other hand, is quite different. This is the kind of result you saw when I was playing with the type function before. The type of a new class object is the object's class, where the old style object's type was instance. And like you saw before, the type of a new style class is type. Back to my type of type being type, found with the type function. Okay, that's Python 2. How about Python 3? I'm in a new REPL. 3.11.2. New REPL, new class. Let me instantiate some dessert. Sunday, yummy Sunday. I apologize, Bono. And the type of Sunday is the dessert class. This shouldn't be a surprise. You've seen this already. The point I'm trying to make is, in Python 3, you no longer need to inherit from object. Python 3 uses the same syntax as Python 2's old style classes, but actually produces new, that'd be 2001 new, style classes. This was done because the old style isn't supported anymore, and there's no need to make Python 3 programmers type out the extra inheritance. Since dessert is a class, its type is type. For compatibility's sake, you can still do it the old new way. Love me some gnocchi. Type of the instance is the class. And the type of the class is type. Essentially, although not necessary, you can inherit from object in Python 3 and get the same result as not doing it. This makes compatibility easier when you're writing scripts that need to work in both, say, 2.7 and a 3 variant. Let's get graphical and visualize the new style. Starting with my Sunday instance, which was created by the dessert class, and the type of dessert is type, and the type of type is type. Does the picture help? Saying the type of type is type is fun. All right, I'll stop now. The type function can be used as a class factory as well. In the next lesson, I'll show you just that. In the previous lesson, I said the word type rather a lot, hopefully resulting in you learning the class hierarchy in Python. In this lesson, I'll show you how to put that to use, creating classes on the fly. Say it with me. Everything in Python is an object, including the classes. The mechanism Python uses to instantiate class objects is available to you as a programmer. And as you might have guessed, this mechanism is the type function. Let's review quickly. There's my dessert and a Sunday instance. The type of Sunday is the dessert class, and the type of dessert is type. Now let's do the same thing without the class keyword. Here, I've created an appetizer class using the type function. This variant on the type function takes 3 arguments. The first is a string for the internal name of the class. The second, an inheritance tuple, which is empty in this case. And the third, an attributes dictionary, also empty in this case. The appetizer returned by the type function is a class. When I wrote the dessert snippet up top, Python was essentially doing this call to type for me. What do you do with a class? Well, instantiate it, of course. Here's my shrimp instance, whose type is appetizer. And for completeness sake, the type of appetizer is type, which I got by using the type. Yeah, I know, I promised to stop. Sorry about that. Let's do that again, but with something a little more complicated. This creates the dip class that inherits from appetizer, hence why appetizer is in the second argument's tuple. Dip classes have an attribute called description. Note that this is a class, not an instance, so the attribute here is a class attribute. It'll be shared by all object instances. Who doesn't love a good salsa? Type of salsa is dip, and type of dip is type. Because of inheritance, salsa is an appetizer. And there's the class description attribute. Let's do another one. Creating the stuff class that inherits from appetizer. Like dip, it has a description. And I've added a content count attribute. Total things is a lambda. So let's stuff some mushrooms. Mushrooms are appetizers. There's one thing stuffed in the mushroom. And one thing inside, plus the mushroom itself gives me two things in total. Note that total things is a lambda, so I need to use parentheses to execute it. I'm going to convert mushrooms to a string. And that's the usual default stringification of an object. To get something else, the object needs a dunder string method. Want to guess what I'm going to show you next? Stay with me for a second. This function might seem a little strange on its own, but imagine it as a dunder string method of the onToast object. That makes sense, right? So let's create onToast, inheriting from appetizer. OnToast has a toppings attribute. And similar to the lambda, I can add a function as an attribute, naming the attribute dunderString and pointing it to a reference of the toString function turns toString into a method on the onToast class. If I were writing an actual method inside a class block, I'd have used self instead of obj as the argument to toString. I didn't here as I didn't want to confuse you by using that convention outside of a class block. Remember, the name self is just a convention. You can call the first argument to a method anything you want. Other programmers may hunt you down, burn your house to the ground, but you can do it. And there's onToast, burnt or otherwise. Bruschetta goes nicely on toast. And when I convert bruschetta to a string using the string function, dunderString gets called and the toString function, which is now a method, gets invoked. Funky, huh? The mechanics behind classes really are just syntactical sugar, making classes clearer to write. But underneath, you've got some very function calling, object attribute applying, everything's an object kind of stuff going on. Why is invoke spelt with a K, but invocation is spelt with a C? English is a weird language. Anyhow, invoking something in Python is done with parentheses, and underneath this results in a dunder call method on an object executing. Because, like, you've heard of everything is an object, right? In practice, writing a dunder call method allows you to treat object instances as callables. This can be handy in its own right, but understanding it is needed before taking the next steps. So let's dive into what seems like a tangent. Back in my handy REPL, going to import the subprocess module. And now I'm going to define a class that executes multiple calls to subprocess.run. The init takes the actions argument that is a list of actions, where actions themselves are lists. That's because that's what subprocess run expects. The doIt function is where subprocess gets invoked. It loops through the actions and calls subprocess.run on each. If you haven't used subprocess run before, it takes a list. The first item in the list is the command to run, while the rest of the items in the list are the arguments to the command. I've instantiated an action object calling the echo Unix command twice, passing in some strings to echo each time. And calling doIt does it. If you're not a Unix person, echo is a command line tool, kind of like print. Whatever you hand it, it prints out to the terminal. The response here isn't actually the REPL, but the subprocess execution spitting something back to the REPL. But you said something about dunder call, I hear you say. Let's try it again in a different way. The only difference this time is I've named doIt dunder call instead. Having done that, how I execute the action is different. There's my hellos again. And instead of invoking doIt, I call hello like it is a function. You can do this with your own classes and make objects that look like they're functions. And since functions are also objects in Python, yeah, I'll save that one for another course. Next up, what you came here for. It's been a bit of a twisty road, but you've got enough background now that you can build a metaclass. In the previous lesson, I showed you how to dynamically create a class using the type function and how to make an object callable with dunder call. In this lesson, I'll finally be getting to the subject matter, metaclasses. You saw how the dunder call method can turn an object into a callable. At a more general level, you can state that in Python, parenthesis invokes objects. And well, you may have heard somewhere that everything's an object, right? Consider print without the parenthesis. It's a reference. But call it with the parenthesis and you're invoking it. See, that parenthesis thing works for everything. So classes are objects, and when you use parentheses on the class, you're invoking it. It's callable. All classes inherit from the base type Metaclass, and that Metaclass has a dunder call method. See, that's why the dunder call tangent in the previous lesson. It's all fitting together. So what happens when you invoke a class? The type Metaclass creates the object and calls two dundered methods on it, dunder new and dunder init. There are default implementations of these methods, so if you don't define them, the parent's methods get called. Dunder new is responsible for creating the object, which I'll show you in a minute. And dunder init you're probably familiar with. This is why you'll occasionally come across someone making the argument that the init method is not a constructor, so you shouldn't call it that. In most languages, the constructor creates and initializes the object. In Python, these things are separated into two parts. Don't let that stop you from calling it a constructor. Everyone knows what you mean, and if someone challenges you, you can go to town on them about types and callables because you just learned all that. All right, let's go play with some of these special methods. I'm going to use the same technique as before, creating a function, then changing it into a method. I'll start with the new function. The primary purpose of new is to create the object. You can do that by using the dunder new method on the object. Yep, type of type isn't the only thing. You've also got the object. You pass in a reference to the class to be constructed, and Python instantiates an instance for you. Once you've got the instance, you can add attributes to it. And the one thing you must remember is your dunder new must return the constructed instance. With the function defined, let's use type to create a class. In its attribute dictionary, I'm turning the new function into the dunder new method. Now I'm going to create some ceviche. Raw seafood. And because dunder new was called when the instance was created, the description was added as an attribute. Of course, this is an overly complicated way of doing this. You can simply override dunder new in your class syntax definition, just like you override dunder init. But then you wouldn't be learning what I'm going to show you next. You just saw how dunder new is called when an object instance is created. But what if you want something done when the class itself is created? The type metaclass does have a dunder new method, but you're not allowed to override it. There'd be no way to instantiate, and ultimately the buck has to stop somewhere. So instead, Python provides the metaclass argument to the inheritance syntax. You create a metaclass like a regular class, except it inherits from type and typically overrides the dunder new on the class. The resulting metaclass can then be passed into the inheritance part of the class definition. This is done inside the parentheses where you indicate inheritance from another class. You provide the metaclass keyword argument and pass it the metaclass to be used as a hook into creation. Let's go turn all that word soup into a concrete example. The metaclass I'm going to show you contains a simple counter that gets incremented when it is used. This is kind of like having a counter that tracks how many instances of an object there are, but instead this counts how many classes inherit using this metaclass. The first step for a metaclass is to define a class that inherits from type. I almost always use the word meta in the name of the class to help provide some clarity. The other technique I've seen, and you'll see later, is to use the word type in the name instead. In order to be able to count things, I need a counter. So here I've created an attribute on the metaclass. Pardon the lack of spacing here, the REPL doesn't like blank lines. I'm overriding the dunder new method of the metaclass. Note the arguments here. Do they look familiar? They're the same three arguments that the type function uses to create a class. Inside the dunder new, I'm using super to invoke the class creation of the parent, which will be the new type metaclass. This is what actually creates the class instance. This will be the instance of the class using the metaclass, not the metaclass itself. And here is my side effect. Each time a new class is created using this metaclass counter, the metaclass count attribute is incremented. I initialized it to 0, so the first creation will have a count of 1. Finally, like an object's dunder new, the class's dunder new needs to return the created class. Let's use the metaclass by including it in the inheritance syntax. This defines the pie class. Pie. And uses the counter metaclass by passing in a reference with the metaclass argument. Note that it's a reference to metaclass. It isn't invoked. There are no parentheses here. I prefer simple pie. This one's more of a crust. There's nothing inside of it. Make some apple. And some raspberry. And let's see the count. Did you expect that to work? Remember, the count attribute is on the metaclass, not on the class. It isn't a class attribute. I can get at it though. Using the dunder class attribute, the count is 1. Having Apple and Raspberry isn't the relevant part. This code doesn't care how many instances of Pi there are, only how many classes use the metaclass counter. So far, there's only one, Pi, so the count is 1. What's better than Pi? Cake, of course. Cake is definitely better. I'll fight you. Like Pi, here I'm using the Metaclass keyword to use the counter Metaclass hook. And like Pi, I'm going to keep it simple. Some cake. Some more cake. And there's the counter. 4 object instances, but only 2 classes, so the count is 2. I'm not sure why you'd want to count how many classes are based on a particular metaclass, but the important part is the side effect. You can now hook when a programmer defines a class and do things with it. What kinds of things? Well, I'm glad you asked. In the next lesson, I'll outline some common uses of metaclasses in the real world.